Hi, today we got a special parallelogram. Nothing for those of you that weren't here for parallelograms. But for those of you that were, we're going to talk about geometric properties of rectangle, rhombus, and squares. How can we conclude all these things? I'm just going to go over our learning goals. Prove and apply properties of rectangle, rhombus, and squares. Use them, solve problems, and prove that if I'm given a quadrilateral, it is a rectangle, rhombus, or square. First, let's talk about a rectangle. A rectangle is merely a quadrilateral with 4 right angles. How many? 1, 2, 3, 4. Right? What I underline. My square is not a square, it's a rectangle. My rectangle in the right here. Oh, see? Yeah, when we leave school for a week, things happen. Okay? Things happen. Alright, so we've got a quadrilateral with 4 right angles. That's merely a rectangle. There's a few more properties though that go along with it. You ready? Okay. First off, if you have a rectangle, I'm sorry. Yeah, well, let's say this. If the quadrilateral is a rectangle, then it is also a parallelogram. Yeah, I'd write that down. It's kind of important. Okay. All right. And so here's what goes along with that. Those 5 properties of the parallelogram that we talked about yesterday. You got me? So remember, once you say something's a parallelogram, these things have to be true. Opposite sides have to be parallel. The opposite sides have to be congruent. The opposite angles have to be congruent. The consecutive angles have to be supplementary. And the diagonals bisect each other. What's cool about a rectangle, not only does it have 4 right angles, but also the diagonals are congruent to each other. So in a rectangle, my diagonals are congruent. Remember, yesterday we said parallelogram means that A to the bisect point is equal to C to the bisect point, right? Because that's what the bisect does. B to the bisect point equals D to the bisect point. Well, guess what's true today, yo? Today, they are congruent to each other. Okay? Yep. They're congruent to each other because A to C is congruent B to D, and they're still meeting at that point. Okay? All right? But the big point is this. The big point is that this is congruent to this. Okay? Because that's how a lot of the problems are going to occur. And we'll see some triangles and all that stuff. I know. It's so cool. It's like, this is where nerds will come out today. All right. All right. We also need to talk about rhombus. Rhombus is just a quadrilateral with 4 congruent sides. Okay. Okay. Picking up what you're talking about. All right. Rectangle, 4 right angles. Rhombus, 4 congruent sides. All right. You'll find properties that go with a rhombus end up being a little bit more difficult to recognize than properties that go with a rectangle. Okay? So make sure you get this next slide. Make sure you get it down. A rhombus and a parallelogram? Sure. What's one difference? All 4 sides are congruent here. That wasn't true for the parallelogram, right? No, that's a good question. No. The angles don't have to be congruent. Okay? If they were all congruent and it was a rhombus, but we're getting to that. Okay? All right, here we go. First thing. If I'm talking about a rhombus, then I'm talking about a parallelogram. with that, Mr. Hobbs? We'll say it again. The 5 properties of a parallelogram. The opposite sides are parallel. The opposite sides are congruent. The opposite angles are congruent. The consecutive angles are supplementary. And the diagonals bisect each other. But one of the things that we need to understand about a rhombus is this. These diagonals are perpendicular. Okay? When I say perpendicular, there should be a little thing that goes off in your head that says right angle, right angle, right angle. Right? But check it out. It's kind of hard to look at right here, but I got 4 different right angles right here that are formed in the middle. Okay? You got that, Cassidy? Okay? That's crucial to understanding about a rhombus. Where the diagonals intersect, they form right angles. So cool. I know. So cool. Okay. Final key property that you need to understand is this. The diagonals are angle bisectors over here. Okay? They are angle bisectors. Cut those angles in half. Now, since it's a parallelogram, the opposite angles are already congruent, right? But they also form a bisector. What does a bisector do to an angle? Tori, you'll work, jump in here. Bisecting an angle. What does that mean? Perfect. So you didn't even have to be here, right? Cutting an angle in half means bisecting. Okay? Bisect. Cutting it in half. 2 congruent halves. Right? Have any more time on this one? So when you get here, make sure you say the diagonals bisect a pair of opposite angles. Okay? So if you're keeping track at home, we got parallel lines cut by a transversal, 2 alternate interior angles on each side. So you can just think about that. This is pretty cool, right? It's free. Okay. Doesn't mean it doesn't cost you something, but it's free. You didn't even have to pay for this today. Okay. Oh, I'm sorry. Please tell me, CJ. Oh, but you. Yeah, you. I mean, how much is personal income tax? $100. Where'd you work? Okay, so how'd you say $100? Say what? Personal income tax, not sales tax. Personal income tax. And if you did work, and you're under 18, which, yeah, you are. Parents put it on their tax. All right, so check this out, guys. Just like a rectangle, a rhombus is a parallelogram. You can apply the properties of a parallelogram to a rhombus. So I've already went through that. Right? Sometimes when we talk about rectangles, rhombuses, and squares, we refer to them as special parallelograms. Okay? Not proportional. Special. Okay? No, don't write it down. Just write this down. A square. It's a very basic definition. Square is a quadrilateral with 4 right angles and 4 congruent sides. Null there. Okay? But what is about to occur will blow your mind. A square is the combination of a parallelogram, a rectangle, and a rhombus. Oh, I'll tell you how. You just give me the chance. It has all of the qualities of a parallelogram. If you need a reminder, I'll tell you. The opposite sides are parallel. The opposite sides are congruent. The opposite angles are congruent. The consecutive angles are supplementary. And the diagonals bisect each other. Has all of the aspects of a rectangle, 4 right angles. has all of the aspects of a rhombus, four congruent sides, diagonals that are perpendicular, and bisecting angles opposite. Hot thing, right? Have I? I'm just excited. It's just a good day. Okay. Not still great. Great day. All right. Let's try this out real quick. See how we're doing. Okay. See what we get here. All right. Y'all do this one. Slab of concrete is poured with diagonal spacers. Rectangle C and RT. CN is 35 and P is 58. Find each length. A couple minutes. Ready to go. So, yes or no? I have a rectangle here. Landon, Gilbert. Landon, do I have a rectangle here? Okay, good. It tells me it's a rectangle, right? What do I know about a rectangle? Right on, man. Got four sides. I like where your head's at. Got four sides. Four angles. Perfect. What kind of angles? Four right angles, okay? Is a rectangle a parallelogram? Yes. The opposite sides of a parallelogram are what? So this side's congruent to this side, and this side's congruent to this side, correct? So if CN is 35, then what's DR? Well, that was just knowing my definition of a rectangle, right? Really just knowing the definition of a parallelogram. Okay? Oh, and we want us to know that this is feet, so make sure you get feet. Don't forget feet. Okay? All right, next, I know this. Diagonals are congruent to each other in a rectangle. So NT is congruent to CR. What is NT here? 58. Why am I dividing it by 2? Because it's half. So it should be what? Yeah, 29. 29 what? Okay, 29 feet. Okay. Any questions on that? Just definition, straight up. Next one's hard. Yeah. And begin. Okay, I draw this one too. This one's tougher, and I'll show you why. In the meantime, Braden. Braden, what is QP? Oh. What do I have? What kind of shape do I have? A rhombus. What is true about a rhombus? All sides. Okay, so this means that QP is equal to QR is equal to RS is equal to SP, correct? Pretty much. All right, good deal. So, dog, how can I find the answer for QP? Listen to what he just said. He's speaking wisdom over there. 4A minus 14 equals 3A. Because this side has to equal this side. Braden? No. I'll go to my algebra expert. Ms. Faulkner. How do I solve for A here? Okay, you can do it like this. Subtract 4A from both sides, you get negative 14 equals what? What?
Negative 1A.
I'm going to my 1A? Negative 1A. Now what do I do?
And then you take that, then you take negative 1 and then minus that.
You take that. It's speak math already.
You take negative 1 divided by negative 14. Jesus, I can't talk.
So that's what you told me to do. What about over here? What is it? 14 equals A. Braden, is that my answer? No. Probably not your question when I ask it like that, right? No. You got to plug. Plug what? Let's see if Braden can get this right. You got to plug 14 for A. So over here, I do that, correct? Yep. And what is that? You don't have to. It's 42. Okay. So Q to P would be 42. Correct?
Wait, so is RS.
14, 28, 42. 3 times 14. 14, 20. Have you noticed that? They would all be what? 42. All of these would be 42. 4 times times 14 is 6 minus 14 is 42. Yo.
When you're getting 80 from 22, what do you?
If I did 4 times 14 minus 14, I get 42. 4 times 14, 14, 28, 42, 56.
You didn't like that.
3 times A, 3 times 14, because 14 is A. That's what he told me. He told me that. Now I'll go to someone else. Ian, or Ian. I'm trying to find the measure of QRP. That's this angle right here, correct? Ian, here's how you got to start this one. Is a rhombus a parallelogram? Yes. In a parallelogram, the consecutive angles are congruent. No. They're what? And Emily Lightfoot's going to tell you what supplementary means. 2 angles add up to be 180, right? But Ian, it's not 78 plus question mark. It's 78 plus all of angle R. Okay? So 78, I'll do this one in green. 78 plus angle R equals 180. I don't need my algebra expert for this, because this is a 5th grade standard here. Bless you. 180 minus 78 is 102. Bless you again. That's enough. All right. All right, Ian. Another aspect or characteristic or property of a rhombus is that it's an angled bisector. So if the entire angle is 102, what is that cut in half? 51 degrees. So my final answer here is 51.
Wait, what did you say after that?
Okay, sure. 78 plus 102, y'all should be listening to me. 78 plus 102 is 180, right? But one of the aspects, one of the properties of a rhombus is that the diagonals bisect the angles. Miss Sanders is going to tell you what that means. When something bisects an angle, cuts it in half. So if the whole thing's 102, QRP, please, give us all like a clue or something. Well, there's something up there you think you're going to get out. You're out. Did you have another question? I'm done. All right. Hey, y'all, listen. Stay off your phones, and this will go fast. You don't have to write this down. Okay? I just want you to listen, and I think you'll absorb it. All right? First thing is this. If one angle of a parallelogram is a right angle, then that is a rectangle. If one angle is a right angle, then my parallelogram is a rectangle. Okay? Want to know why that's true? It's like this. If it's a parallelogram, the opposite angles have to be congruent. So if angle A is a right angle, then angle C has to be a right angle. And the consecutive angles are supplementary. 90 plus 90 equals 180. Okay? Only takes one. One right angle in a parallelogram tells me that that is a rectangle. Next, if my diagonals in a parallelogram are congruent, then I have a rectangle. Okay? If AC in a parallelogram is congruent to BD, that means that I have a rectangle, which is helpful because it tells me, if it's a rectangle, it's got 4 right angles. Okay? See the principle? See the property in place? Right? One of the properties of a rectangle is that the diagonals are congruent. If I'm given a parallelogram with congruent diagonals, it has to be a rectangle. Then we get to the fun. Here we go. One pair of consecutive sides of a parallelogram are congruent. I have a rhombus. It only takes one pair of consecutive sides. If it's a parallelogram, the opposite sides are already congruent. Okay? That's the part you've got to get your properties of parallelograms memorized, frankly. And now we're just applying it, right? It's a parallelogram. I already know the opposite sides are congruent. It's a parallelogram and consecutive sides are congruent. I know right now it's a rhombus. Okay? Because the opposite, that means that the opposite sides are congruent to everything. Yay! If my diagonals are perpendicular in a parallelogram, I have a rhombus. Here's the big giveaway. If I've got a single right angle in there, that really helps me out. What's a characteristic of a rhombus? All of the sides are congruent, right? Well, another way I can get there is if my diagonals are perpendicular. Last thing, if one diagonal of a parallelogram bisects a pair of opposite angles, I've got a rhombus. Okay? So if those diagonals bisect opposite angles, I have a rhombus. Why, Mr. Hans? Well, this tells me that I've got alternate interior angles. Alternate interior angles are congruent. Two pairs of alternate interior angles are even cooler than being congruent. That means that I've got like congruent alternate interior angles on both sides. Which means I have congruent angles amongst the other ones, which means that everything's awesome. And I've got a rhombus. I don't have people don't do it. All right. Look at this. Watch this in real life. Okay. Well, a carpenter's square can be used to test that an angle is a right angle. How many of you have ever done any carpentry work and used a thing we call a square? Right? Very helpful. How could the contractor use a carpenter's square to check that this is a rectangle? Think about this. Both pairs of opposite sides are congruent, so we have a parallelogram. Now that's some very helpful information, especially if you're doing carpentry work. But it would be easy to do, right? How can I do this? You guys have done carpentry work, and gals do. Make XY, right? And cut how many of them? 2. Right? I cut 2 of the same length. Okay? And that creates XY, and then the other one would be WZ. And then I can take a measurement needing XW and cut how many? 2. Right? The same congruent sides. The opposite sides are congruent. Okay? Check this out. I then use the carpenter's square to see if one of the angles is a right angle. Because remember, if one of the angles is a right angle, then it's a rectangle. Okay? So, to put this in, so guys, okay? So just know that if you get one of those angles to be a right angle, you're good. Okay? All right. Here's what I know. I know that AB is congruent to BC, is congruent to CD, is congruent to DA. G, what does this look like it's going to be? A square. What is it right now? What is it right now? Rhombus. 4 congruent sides means it's a rhombus. What information is needed to conclude that ABCD is a square? What is a square? 4 what? Right angle. 4 congruent sides, 4 right angles. Time out. Time out. How many of these angles do I need to prove is a right angle? 1. Thank you, children. Okay. Remember that in real life one day. Gentlemen and ladies, maybe, okay? Because it can, create happy times later in life, okay? If I prove that one of these is a right angle, all the other ones have to be right angles, right? Why is that true, Mr. Hobbs? It's already a rhombus. If it's already a rhombus, it has to be a parallelogram. And guess what's true in a parallelogram? My opposite angles are congruent, my consecutive angles are supplementary. So if one of those angles is a right angle, the opposite one has to be a right angle, and the one right next to it has to be a right angle. Okay. All right. I think that's all I got for today. So.